Again, I want to welcome you all to IndyPy. My name is Calvin Hendryx-Parker. I am CTO and co-founder of 6 Feet Up, and also one of the co-organizers and co-founders of IndyPy. So tonight we're going to just a quick discussion, a quick tutorial, a little bit about Greengrass. Who's familiar with AWS's Greengrass product? Has anyone tried it out? It's pretty cool. That's why I'm talking about it. So let's just go dive right in, because I got some cool demo stuff we're going to do. I actually have a Raspberry Pi up here running on my battery pack that's connected into our Greengrass cluster, and we'll talk about what that means and how it's actually hooked up. So Greengrass is fully managed edge services. It is basically the ability to provision into Internet of Things type devices by running a small kernel of an application on that hardware embedded into the existing systems. So for example, with the Raspberry Pis, there's just a package you can download, Bootstrap, and actually be off and running locally with, on your local little devices, a Greengrass kernel. And that gives us, this, again, secure communications, but then group management of the cores. So you may have hundreds or thousands or tens of thousands of these devices out in the wild, and I don't know how you would manage that many devices by hand. So this gives you a mechanism or a way of doing over-the-air provisioning and updates, so keeping all the software update and secure. Some of the features they've added over the last year are actually very focused around security and auditing of security of those devices. So who's heard of an Internet of Things device that's been insecure? Like all of them, right? So that's kind of a main focus recently on Amazon's Greengrass platform is actually how do we detect devices that are breaking policy, doing activities they shouldn't be doing, going outside of where they should be doing, and actually monitoring that and managing that piece for you. And I'll show some of the UI, kind of how you manage that on a very small basis, obviously, because I've just got one device managed in my Greengrass group. But this kind of the ability to scale that up into thousands is really, really interesting. Now I said it's fully managed at the edge. Really what you're getting is a couple things. The big one, the easiest first win you'll get by using something like Greengrass is Lambda at edge. So Lambda is the serverless technology from AWS. So if we've had a couple serverless tutorial talks in the AWS and at IndyPy. But serverless means I don't have to worry about servers anymore. I don't care about servers anymore. I'm not managing hardware. I'm not managing OSs. I'm not even managing most of the junk leading up to just where my actual code runs. It's function as a service. That's what Lambda is specifically. Serverless is a bigger term, but we're talking about function as a service. And I'm looking at Caleb because we have a debate about this nearly weekly on what serverless actually means. But tonight we're just talking about function as a service. You write a single function. Your code can execute one time, or can execute 100 times, or 1,000 times, depending on how many invocations have been requested. But in the traditional sense of AWS's Lambda, those invocations are happening on AWS's data center. With the Greengrass invocations of Lambda, you can actually have your code execute at the edge of your network. So wherever you have your IoT devices, they are those devices that are closest to the data are going to be running the code right at the edge. And in addition to things like that, we're going to have a lot of other benefits we get from having our devices close to where we run our data. Because if you had to rely on sending the signal or sending the data back to the AWS cloud, if you were tens or hundreds of milliseconds away from wherever that data source was, maybe you couldn't do certain things like inference and ML and AI in a very efficient manner. But if you can actually move that processing and all that down to the edge devices where it's all happening, you get a much faster response time, and then you also get some other abilities that I'll talk about in a bit. One of the other things we get is offline operation. These IoT devices may not always be on reliable internet connections. They may not always be able to talk to the AWS cloud itself, but you still want to be able to leverage collecting that data, getting the trends over time, understanding and doing anomaly detection, all the pieces that kind of make up why you're putting sensors out into the wild anyway. With the offline operation, each IoT device out in your infrastructure have what's called a device shadow. And so they have a state they maintain locally, and there's a shadowed version of that state maintained in the cloud. And so if maybe 4 or 5 times a day your internet connection comes up, those states will then sync So you can actually send new state down to the devices, and vice versa. The devices can send new state up into the cloud, and your applications can still leverage the data that would be at that edge location. It may be somewhat stale, but it should be in sync with, with the last time you actually got a reliable connection to the network. And now you can also send state changes in a reliable way without having to worry about the devices actually being connected in real time. Another aspect that Greengrass gives you is local messaging. You may, again, in this area where you may have limited internet connection, you may have a cluster of Greengrass devices, a lot of IoT devices out in some kind of field someplace, and they all can talk to each other using the Greengrass protocol. So under the Greengrass messaging protocols, they can actually talk amongst themselves without having any connection to the AWS cloud. So that you've got lots of little sensors that are maybe embedded devices that can't run the full Greengrass. Those can be now talked to by, say, larger maybe Raspberry Pis or whatever the piece of hardware you have more locally in that area. So they use the Greengrass SDK. So each time you load up and deploy these serverless Lambdas to the Greengrass devices, you'll be using the Greengrass SDK, and part of that SDK includes this local messaging component where they can actually discover and talk to each other. So they can do things like processing rules. They can process the rules locally at the edge before they get sent up into the cloud. That gets important when you're talking about things like if you were to post into DynamoDB, which is the kind of the object NoSQL database in the AWS cloud. If you were posting your data on a 1 second or 1 minute interval, that gets very expensive because you're doing lots of requests and you pay for what you eat when you're in the kind of cloud native world. If you can batch those requests up and send them all as one batch, maybe you don't care if your data is a couple minutes old or 5 minutes old or 10 minutes old, but you still want the granularity of, say, every 1 second to 10-second type data points. The Greengrass allows you to batch those up and then send periodic batches of the data up, saving you money on your AWS cloud bill. With the AWS serverless, in normal AWS serverless like Lambdas, you don't have access to any kind of hardware. Basically, you're running inside of a container that has no access to the physical layer of the server that it's actually running on. This is one area where there's a big difference between AWS's Lambda and the Greengrass Lambda, is when Greengrass, you now have access to hardware on the device. So if you've got a Raspberry Pi that's got all these GPIO ports or sensors or even the camera or any of the other pieces of hardware that are running on this device, you can actually access that hardware from those running containers. Like the instantiation of the Python environment gives you access to those specific pieces. So now you can collect data, collect images, do all the data processing you would do, but at that edge location, as opposed to having the very limited sandbox when you're dealing with the AWS Lambdas on the AWS cloud. And one thing I ran into while putting together the demo for tonight, I was trying to actually find the temperature cores. Like there's 4 CPU. This is a Raspberry Pi 3. There are 4 CPU cores on this Raspberry Pi 3 die, and I was trying to find the temperature of the cores themselves. There's a built-in, if you just install Raspbian, there's a command line tool that allows you to access the system on a chip and get access to the sensor data really easily, and it's built into Raspbian. The Lambdas on edge at the AWS Greengrass would not let me execute that command because it's going to run as a restricted user still and still run in a sandbox. There's very specific rules around which pieces of hardware you have access to and which pieces of the file system you have access to. So for example, you can access /proc and /dev, but you can't necessarily access /sys, where there may be specific system data for the chip itself. Now, you can optionally turn on access to sys, but you can't necessarily turn on access to just arbitrary commands. They're still running in a very restricted container. So if you try to do, for example, subprocess and do a popen, it'll be like command not found. We're really running in a very limited shell that has just access to Python and the access to the hardware that has been allowed from the Greengrass infrastructure at the interpreter level. There's also Greengrass connectors. I won't go too deep here, but basically gives you access to third-party hardware, third-party devices, other APIs, other on-premise software. So you may want to check if you're running certain kinds of software and processes on site. There may be Greengrass connectors ready to go for you to use inside the Greengrass pieces. Another awesome piece here is the ability to run machine learning models at edge. So you can actually do local inference. You can take models that you may have trained on SageMaker or with other machine learning tooling, and you can access those or deploy those over the air to your IoT devices, and then run some level of inference at that edge point. Again, it kind of depends on the hardware you're running it on, but there are some pretty powerful boards out there that allow for this. So you can reduce costs basically without having to transfer all that data back to the cloud to do the inference, and also the latency that would be involved with doing that. You can now run some of those simple or even fairly complex inference jobs right at the edge hardware. There's tons of hardware that is supported. Just mentioned Raspberry Pi, but some of these, and this is actually an old list, but there's some pretty serious embedded boards that are now having GPUs on board for doing basically machine learning at edge. So with the Greengrass now, you have the ability to manage that, deploy simple serverless pieces out to those edge nodes, take advantage of that hardware that's sitting inside those embedded devices, and then actually deploy to lots of existing IoT hardware as well. So now kind of for the real meat of this, actually a quick start. If you have a Raspberry Pi at home, it's actually super easy to get going. And I don't say the word easy lightly because it's a tricky word, right? But you can export out, oh shoot, it cut off the very bottom there. Let's see if I can scroll. If you want to play, it's very easy to play. If you log into your AWS account, you can actually get your own API credentials, so your key and secret. I don't recommend using your own key and secret to actually provision the device. What you want to do is actually do an assume role where you give a temporary security credential. In this case, that's the command line there to give a temporary role to your current session, and then copy the output of that into your terminal on your Raspberry Pi. So you can export out key, ID, key, and token. Actually, I can show you what that looks like. Let's see if this, here we go. Here we go. Now I'm okay showing this on the screen because these expired. These credentials will expire after a few hours, so it's nice for being able to play with something, throw it away, and not have to worry about accidentally committing your security tokens into GitHub or whatever. But when you run that command, you will get a JSON payload back that has the access key, the ID, and that session token in it, and the expiration. Be careful, because I ran into this morning at 4 a.m. when I was doing my demo. I had made a key earlier in the morning and then came back a couple hours later and it had expired. And I was like, oh, my stuff's not working. My hello world was just totally failing. It took me the rest of the day to figure out, well, some of the stuff happened in between. But I figured out, yeah, that's what happened is that my actual credentials had expired and I tried to reuse them again. So just to be aware that they are transient and will expire. And then from the Greengrass getting started page, they basically have a one-liner you can copy and paste. It does a wget against a bootstrap shell script. It changes it to executable. I don't know if I can, it's probably not even important if I do. No, let's see if I can go smaller. No, doesn't matter. But basically all that does is it runs a shell script that downloads all the Greengrass software to your Raspberry Pi on just a stock Raspbian. So you don't have to install anything special. It will use pip and apt to install any dependencies that are missing. It runs mostly Python under the covers, so it's for us Pythonistas, it's pretty easy to kind of grok what's going on. You will have to do one reboot because it has to do some kernel level tuning to allow for certain kinds of access. And once you do that, you're up and running, and then you'll come back in, reboot the device, run the script again, and you'll be online and ready to go. So once you've done that, what you'll see, let me put this up on the screen. Ooh, that is, Oh, that's too small. Once you log back into your AWS console, you'll come to if you just search for Greengrass, you'll come to the AWS IoT portal, which includes more than just the Greengrass bits. Bits have got some of the other management pieces in here. But you can get an idea of kind of activity. These are all invocations for this Raspberry Pi that's actually running up here right now. And if we go into Greengrass, that hello world getting started stuff actually gets installed for you. So you'll have already pre-built into your portal this Greengrass device group. And that's kind of where a lot of the magic happens, is in this device group. From here, you can see all the deployments you've done. So you'll write Lambdas as normal, except you'll include the Greengrass SDK into it. And then you have now the ability, once the Greengrass SDK is in that Lambda, it can actually be deployed to these edge devices. And that happens down here. So if we look at the Lambdas, I've got 3 Lambdas that are currently in here. These are all just configured over here in the standard Lambda area of AWS. So if we actually click on the hello world, you'll see the code for that right here. And this is all in the SDK as well. This hello world code is in there. If you download the SDK, you'll get access to this code. The only thing that is required, though, for this to work inside of Greengrass is to have the Greengrass bit in there. Oh, you make that bigger? Let's see if I can make that bigger. There we go. So you'll see that there's a folder inside of this Lambda called Greengrass SDK. When you package up your Lambdas, you can package in other dependencies you would need. Because normally if you just run a Lambda, you've got access to the standard library of Python, but you don't necessarily have access to external libraries like requests or Greengrass or any of the pieces you want to use for, like, say, even machine learning. You can pack a lot into a Lambda if you're tricky and careful. But with the Greengrass SDK available, these will now show up as available to add into, over here is your Lambdas. So if you click on Add Lambda, you'll be able to choose an existing Lambda. And only the Lambdas that have the Greengrass SDK installed will show up in this list. So if you don't see your Lambda showing here, you've not bundled your Greengrass SDK with it. In the slides for this talk, I include a demo folder that has a make file that shows an example of how to basically build a zip file, so you can upload the whole thing as one zip file bundle. So if I go back over here, one of the options you have for uploading, because who loves coding in a web browser? Oh, a couple of people. I'm impressed. I don't. So you can actually not edit your code in line. You can actually upload a zip file. And when you upload the zip file, you just pick your pre-built function zip file right here, which I will not do right now. So once the code's uploaded, you've created your Lambdas inside of Greengrass. You now, before you deploy this down to your Raspberry Pi, you will want to, let me cancel this. You're going to want to hook up events. I mean, a lot of the Lambda system is built around events running inside the cloud. And these all use MQTT, so you can actually send events to certain topics and listen on those topics and gather that data in a asynchronous way, which is really handy. So to do all that, you do these subscriptions. So inside subscriptions, you can basically say, I'm going to have a source, which is a Lambda, my target being the IoT cloud, which is where I want the data to flow into, and from there I can do with it what I want, on specific topics. So you can see I've got a couple ones here set up for my hello world. And then once those connections have been made for the various topics, you can test it, which is kind of handy. So if you come into the test and, for example, subscribe to this hello world topic, there we go. Okay, this is data coming live off this Raspberry Pi. And so I was actually working on this hello world like literally up until the moment I started doing announcements here today. And I told Cameron about this earlier. You can see the IP address. I'm actually, because I knew I could get it connected to the Wi-Fi, I didn't know what its IP address would be, so I could actually shell into it and show you how to debug one of these things. So I added into the hello world to basically output the IP address, my local LAN IP address using Python on here. So I can now register these on Wi-Fi addresses, get the IP address for them locally if I needed to access them for debugging reasons. But right now what's happening is just every 5 seconds there's an asynchronous event loop running. This is so with another big difference from standard Lambda to the AWS Greengrass Lambda, you can run long-running processes. Like I can have one Lambda that just runs eternally. So if you go look at that hello world script, it has an event handler in there, which is this typical way you interface or kind of have your entry point into AWS Lambdas. It basically is a blank implementation there for the event handler, and it has a Python function, and it just uses asynchronous and threading to fire up and run every second, just say repeat running the same code again. So you can do some polling stuff, you can do asynchronous code, and you can have fully long-running processes running on a little device out in the field someplace. A couple other quick little demos here. I've got 3 running on here to show off 3 different activities. So there is one that's going to count instance invocations. So I'm going to subscribe to the hello world counter topic. But nothing has happened yet. You'll see there's no events have come in. This one is triggered by an event coming down from MQTT. So if I actually send an event down the trigger topic, it will trigger a run on the Raspberry Pi with an invocation count. And the invocation count, right now there's just one that's running with a sleep of 20. And so if I hit it a few times, you'll see they won't come in yet because they're basically waiting for that 20-second sleep to happen. And then you'll see that there's still invocation count 1. After that 20 seconds expires and the next one comes, you'll see I get I guess the invocation count 2 there. So this one's been invoked twice. And then we'll have a new one spawned after the 20 seconds, which will start, again, the counter back at 0. So there are some, you could have long-running variables inside of those threads, and each invocation can then have its own process, or depending on how your application is running, share an existing kind of warm Lambda that's running on your IoT device. And then the last demo I want to show is actually accessing the hardware. So I built this one's not a long-running Lambda on here. This is just basically a event-based Lambda. So each time I send an event, it'll trigger a brand new invocation of the Python script. So if I subscribe to this topic for CPU, and similarly I will do a trigger topic. And this code actually reads out a proc, grabbing all the details of the processor cores, just as an example to show that you can actually reach into the file system or the device details on the actual hardware itself. Whereas with a normal Lambda, you wouldn't be allowed to read that. There wouldn't be any useful data there. Let me show off that code real quick. No, that's not the right one. There we go. Oh no, that's the slides. Well, can you just read that? Okay, good. So I've got inside the slides there's a demo folder. So if you just install the requirements.txt, if I cat that, it brings down the Greengrass SDK, the latest version for it. And then if we look at the get IP, this is my, it's my hacked little function basically to return the IP address with Python. So if you make a connection out, you can then see what interface that connection went out on, and then I grab the IP from the socket connection. So a little hack there. And then the get temp one. So this is accessing, we'll open read-only, it's fine. In this case, our code, we import the Greengrass SDK, we instantiate a Greengrass client, passing it IoT data. There are two different ways you can instantiate the client, one dealing with IoT data, the other one allowing you to call other lambdas that would be on the IoT device itself. And then I open up, proc/CPU info, I grab the text, and then I just publish it to the MQTT queue for hello world CPU. And then you can say I put in logging, so like the info logging and error logging, which I found today is very helpful for debugging why the heck your thing's not running. And so if you want to see why where those logs show up, on the actual Raspberry Pi, it'll install into the root file system a Greengrass folder, and then there'll be a var log user, like whatever region. So your Greengrasses are tied to specific regions inside of AWS, and then you'll have this instance's ID. And each of your lambdas will have their own log file in here, and so you can just tail those in real time, which is super helpful for debugging like what's going on. So if you look at git temp, standard Python logs, but you get a lot of the extra Greengrass invocation stuff wrapped around it, so you can see a little more context as to what's happening. All right. Again, that's the hello world code that's actually in the SDK itself. Nothing super, super exciting. Last little bits, as far as Greengrass goes, you have additional access to things like the secrets manager. So if you have API keys and you're using the AWS key management and key store, secret store, you can actually store your secrets inside of the Greengrass secrets manager, and then devices can request secrets on demand, kind of like a Vault or other secrets management tool. Those also work with the Greengrass connectors, so if you've got API keys for software on-site or on-premise, that you can actually have the secrets stored inside of the Greengrass system, which makes it easy to do things like rotating keys. So how do you rotate keys on 1,000+ devices? This is how. It may cost a little more than if you kind of rolled your own, but I think the headache and time saved is probably worth it. Speaking of costs and pricing, there's like a free tier for playing with it, kind of like with everything else on Amazon. You get 3 devices for the first year. Up to 10,000 devices, it's 16 cents per month per device. And if you do an annual upfront commitment, they'll give you like a 22% discount. I assume after 10K devices, they're like, you got to call them, that kind of thing. So basically, you pay for the 16 cents a month per device for the management fee. You still will pay for all the transfer fees. So data transferred from the Greengrass to IoT devices up to the cloud, storing into AWS or to Dynamo or wherever you may be putting that data, you're still going to pay for that transfer. You don't necessarily pay for invocations like you do on AWS Lambda for the serverless. So you basically pay in the cloud what you normally would pay for transfer and storage. If you want to know more, there are links here for the Getting Started page and the FAQ. And if you have questions, there's my email address and my Twitter handle. And I'm more than happy to answer any questions. You got the mic there? Perfect. If anyone has questions, I'm happy to take them. Thanks.
Yeah, give him a round of applause. Give my boss a round of applause. Yeah, if anybody has any questions, Robert?
So you showed us device management page, and you've talked about the over-the-air updating, and I assume that was both of the kernel and the deployed software?
Correct. Yeah, so the deployment, I can show that real quick, because it's kind of actually the interesting part here. Oh, that's the listen part. So from the group, you can see there are your cores, which are the devices that are out there and deployed. They got the lambdas. If I change one of my lambdas, I go over to Lambda like I would normally do in AWS. I would edit the code, publish a new live version of it. These you'll see are linked to specific versions. They recommend in the docs, and I think it's a fabulous idea because after I've gone through this pain of not doing it this way, is use an alias for the release name. So you may have an alias like production or sandbox or whatever your alias may be. And in Lambda, you manage your versions. So you manage like version 1 is production, maybe version 2 is production, version 1 or 3 is in staging or sandbox. And Greengrass is always going to look at that one label to see what it should be deploying out to the devices. Once you have updated your code over in Lambda, you still need to come over, well, or from an API call. This all has support through the API and the AWS CLI, but then you call the deploy function here, and so once you do, it's actually going to do it in real time right now. You'll see it goes pending, and then it actually rolls up the code, delivers the payload down to that Raspberry. It's actually delivering it to the Raspberry Pi right now. And so as soon as that goes green, then the latest code would be available on all the IoT devices.
Awesome. Anybody else have any questions? Oh,
Yeah, go
Robert,
ahead.
again?
Yeah.
So is that one device being updated right now, or is that one update of all devices?
So that's going to push it out to all the devices in this group. There's only one device in the group right now.
Okay. Is there some way to see which ones the deployment has succeeded on and hasn't?
That's a good question. I actually don't know on that. So there is like devices in the shadow state, but that's more for calling and setting state on those edge devices versus seeing which devices have gotten the latest payload for the code. Again, they could be offline. When they come online, they would receive the updates.
Any more questions? All right, well, let's give Calvin another hand.
Yeah, thank you very much.